Library of functions. What we're going to do is just characterize a lot of different types of functions with this chart. And let's start by looking at some of the ones that we're already familiar with. The identity y equals x, that's simply y equals 1x plus 0, right? So it has a slope of 1 and passes through the origin. A constant function is of the form y equals b. Well, this also is exactly the form that we identified for the equation of a horizontal line. So anytime we have a constant function which doesn't depend on the input, it gives the same output b for any input x, its graph is going to be a horizontal line. The next category we have is all other linear functions of the form y equals mx plus b. So these could have a positive slope, a positive y-intercept. They could have a negative slope, a negative y-intercept. There's lots and lots of different graphs that could fit into this category. We're just trying to summarize them all with this one form. So the point here is that we want to be able to recognize that if our equation is of the form y equals mx plus b, our graph is going to be a straight line. It's going to be linear. If our equation is of the form y equals x squared or some variation on that, if we have a square on our x variable, we're generally going to have a graph that has the shape of a parabola. And we've seen these already when we were just first learning to graph some nonlinear equations. Another familiar one over here would be absolute value. When we have a simple absolute value expression like the absolute value of x or the absolute value of some linear expression involving x, we're going to have a V-shaped graph. And we've already seen a little bit in our graphing that knowing what shape to expect our graph to take does make it easier to draw that graph. If we're graphing by plotting points, if we know that it's going to be a V shape, as soon as we see that V turn around, we sort of know that we're done. We know what the rest of that shape is going to be. So these are the ones we're already familiar with. Let's go up to the square root because that's one that we're ready to take a look at next. Y equals the square root of x is a portion of the parabola x equals y squared. If I fill in the rest of that parabola, this is a parabola that lies on its side. This is an equation. This is not a function, right? We can tell because this wouldn't pass the vertical line test. But when we solve this equation for y, we would get y is equal to plus or minus the square root of x. Here as well we can tell that this isn't a function because that plus or minus is exactly what makes it violate the definition of a function. However, we can define two separate functions out of that. When we take the positive square root of x, we get just the top half of this parabola. So this would be y equals the positive square root of x, and that's exactly what our formula is here and exactly what our original graph looked like. And then when we take the minus part of that, y equals minus the square root of x, we get the bottom half of this parabola. So this would be y equals minus the square root of x. Just understanding where this graph comes from helps us to remember what it looks like and to understand that shape a little bit better. A square root graph is just a parabola lying on its side instead of oriented up or down, and we only have half of it because we only have the principal square root. We don't also have the negative square root. Now, cube and cube root, these graphs really haven't come up at all. We're just going to look at them briefly and see what they look like and maybe be prepared to identify something as a cube or cube root graph. A cube graph is increasing very fast and has this little kind of blip in the center where it turns almost horizontal for just a second, right? It's almost horizontal right at the origin. And then the cube root is the cube graph flipped around, just like the square root is the square graph flipped around. So it's the same shape, but here at the origin, instead of being almost horizontal for just a second there, it's just almost vertical. It doesn't stay vertical long enough to actually violate the vertical line test. It just turns almost vertical for just an instant and then turns right back around. But basically it's the same shape as y equals x cubed. It's just oriented on its side. instead of going up. And finally, we have the reciprocal graph, y equals 1 over x. This is probably a new graph to a lot of us. What happens with this graph is that the graph actually approaches the axes. So right here, this graph is getting really close to the x-axis, but never quite reaching it. So the graph approaches the axes, both the x and the y-axis. And this kind of behavior has a name. We would say that the axes are asymptotes. We don't really need to know a lot about asymptotes right now. We're just getting exposed to this idea early, and then this will come up again when we start to learn about exponential functions. It'll also come up if you take college algebra and start graphing more of these. This is a rational function because the 1 over x is sort of a ratio or a rational expression. So this is the first exposure we get to these asymptotes, but we can see that it happens here with the x-axis, up here with the y-axis, down here with the y-axis, and over here with the x-axis. In all four of these places, the graph is approaching those axes.